I want to discuss the topic of solving differential equations. A differential equation is merely an equation that involves the derivative of an unknown function. Certainly that's the case here, 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 as well as there. Oh, here as well. Now, as far as you and I are concerned, we're not going to solve differential equations like the last two. In that, the highest order derivative you see anywhere in the equation is not 1, it's 2 here and 4 here. You and I are only going to look at first order differential equations, and even as such, a limited variety of them, if I can say it that way. So the DEs you're going to solve are only going to be first order, and I only have 2 techniques. The first is what I refer to as the technique of separation of variables. I sometimes will subclassify the DE, differential equation, as being separable if it can be expressed in this form. If you can rewrite the DE so that dy dx is equal to the product of 2 functions, one solely in terms of the variable x, the other solely in terms of the variable y, we'll subclassify it as separable, and here's going to be my approach theoretically speaking. So let me take this differential equation. Now watch me separate the variables. So I brought all the x's to the right-hand side so you see this not in some denominator. All the y's to the left-hand side so you see this not in a denominator. And notice I immediately wrote the integral symbol. I would never write this. Because if I wrote that, it's as if I treated this dy and this dx as my independent and dependent differential respectively. These are not differentials. This is a derivative of some unknown function called y in terms of x. So if I separate the variable as such, I am now left with what I hope are 2 integrals for which all the techniques of integration we learned can be applied. Now, if this looks like Harry Potter mathematics, going from here to here, let me justify it so you believe me that it's not really coming in and multiplying both sides by something called vx, and then dividing both sides by gy, the latter of which is legal. So here's my justification. Let me pull out a piece of scratch paper. Let me go ahead and take this relationship and differentiate with respect to x on both sides. Now, on the right-hand side, life is a 100% absolute piece of cake. The variable integration is x. So as far as you and I are concerned, at this stage of our mathematical education, this operator and this operator undo each other. The left-hand side is a bit more complex because notice how y is a function in x and I'm differentiating respect to x. So maybe taking it a bit more slowly. Surely the differentiation process and the anti-differentiation process undo each other. But I just differentiated something in terms of y. So the chain rule tells me to multiply by the derivative with respect to x of whatever that innermost function or next function was, dy dx. But of course now this can be multiplied to both sides, that denominator, and I'm left with this. I'm sorry if I just wasted a bit of your time in life. All I was trying to do is justify why it's legal to go from here to here, because technically speaking, it's just the reverse direction of differentiating and applying the chain rule. So now I've made it legal to separate my variables. Let's get down to some examples.